In part 5 of section 8, we'll be looking at the next algebraic technique called addition elimination. And there's a 4-step procedure again. The first step is the rewrite and multiply step. Second step is the adding of the equation step. And then the third and fourth steps are going to look identical to what we had with the substitution method, that is back substitute and check. So really the only difference between these methods is the very first two steps. It's that beginning part of the procedure. So we're going to use example 8.6 as a means to help us see how these steps work. Now for 8.6a, it does say solve each system by the addition elimination method, but we are not going to need to do step number 1. So we're going to skip step number 1 and go directly to step number 2. You'll want to make sure that you look at all the examples that go with part 5 to understand why this is the case. So we're going to go directly to the addition step. So what we're going to be performing here is vertical addition, just like you would have done in grade school, where you would say, let's add 13 plus 24, and you are taught to line up the digits, and then you would just add vertically going down 3 plus 4 to get 7, 1 plus 2 to get 3, and then you don't have to worry about starting at 24 and then trying to count up 13 to get to 37. You just do two small additions to get to the result that you wanted. So we're going to be performing a vertical addition a lot like this, where we have to have the, not digits, but the terms have to be lined up correctly. So notice that the terms are already lined up. The x's are within the same column, the y's, and then also the constants. So when we perform the addition, I'll start with the x's. 3x plus 3x would give me 6x. 2y plus a negative 2y is going to eliminate, hence the name elimination in this process. So we do an addition to try to get an elimination. So the name tells you really what your goal is in the solving procedure here. So the constants can then add. 14 plus 10 will give you 24. So now we have a brand new equation. 6x is equal to 24. It only has one variable in it, and if you divide both sides by 6, you will get that x must equal 4. So you're able to very quickly get the first assignment of a variable with this method. Now we need to go into the back substitution step. So now we're on to step number 3. Now for back substitution, I'm going to go ahead and label these as equation 1 and 2. It should not matter which equation you plug it into. If I go equation number 1, 3x plus 2y equals 14, and I substitute the 4 in for the x here, I should be able to calculate the y. So 3 times 4 plus 2y equals 14. That'll be 12 plus 2y equal to 14. Let's see. 2y will equal 2, so therefore y must be 1. And if I've done this correctly, then I could also just as easily plug it into the second equation. I should be able to get the exact same result. So let's take 4, and I'll bring this around here, substitute it in for the x. So 3 times 4 minus 2y should be 10. So that'll be 12 minus 2y equaling 10. Negative 2y is equal to negative 2, and what do you know? There you go, y must equal 1. So you only have to do one of those two for back substitution. You don't have to do 2 back substitutions. But I wanted to show you that regardless of which equation you pick, you will get the exact same result. So the proposed solution here would be 4, 1. And the only way to verify that for sure is to plug this in for the original equations, the entire thing, the x and the y. So let me erase this vertical addition here with integers, and I'll do the check up here in the space that we have. So with equation number 1, 3x plus 2y equals 14, we'll substitute in 4 for the 3, substitute in 1 for the y, so that'll be 12 plus 2, which does give me a true statement, 14 equals 14. Second equation needs to be checked as well. We want to be thorough here. 3x minus 2y should equal 10, so that'll be 3 times 4 minus 2 times 1. That's going to be 12 minus 2, which does give me a true statement, 10 equals 10. So there we go. That verifies our result, and I will put it in a solution set and box it in as my final answer.